What's going on, guys? In this video we are going to see an example of summing amplifier. In this particular problem we are going to see how to find out this Vout voltage. Okay, here we have three voltage in V1, V2, V3, and also we have three input resistance R1, R2, R3, and also we have a feedback resistance, that is RF, and we are trying to find Vout. Now we are going to assume this is an ideal op amplifier, and when we deal with ideal op amplifier we have to know two things. For an ideal op amplifier, the voltage in the positive terminal is equal to voltage in the negative terminal. Here the voltage in the positive across the positive terminal is going to be 0 because this is connected to the ground, so this is going to be 0 voltage. And if the voltage across the positive terminal is 0, then voltage across the negative terminal also 0, so this is equal to 0 voltage. Okay, and also when we deal with ideal op amplifier, we have to know that current through the positive terminal and the negative terminal, let's say entering or exiting, it's always going to be 0. Okay, so I current through this one and this one is 0, and those are the two things. Okay, now here we have V3, and if this is 0, this one is 0, this is 0 voltage. Now here we can apply Kirchhoff's voltage law at negative terminal. If we apply Kirchhoff's current law at negative terminal, let's call this one, let's create the names for the current. Let's call this one I3, let's call this current I2, and let's call this current I1, let's call this current IF, and all the current entering this node should exit through this one, because we know that current entering or exiting this positive negative terminal is always going to be 0. So all the current entering this node should go through this one. So all the addition of these three currents should be equal to IF. Okay, so we know that I1 plus I2 plus I3 is equal to IF, and also we know that voltage across the positive terminal is 0, therefore voltage across the negative terminal also 0. So voltage at this point is 0. So if this is 0, then this current, using Ohm's law, we know that current is equal to voltage over resistance. So this is going to be I1, we can replace I1 with V1 over R1, because V1 minus 0 divided by R1, so we can neglect 0 right here, and V1 over R1 plus V2 over R2 plus V3 over R3 is equal to 0 minus Vout divided by RF. So this is going to be just minus Vout over RF. Okay, so this is going to be the equation. Here we are interested in finding Vout, so we can multiply this RF to the other side. So this is going to be, and also we can bring the negative sign to this side. So this is going to become negative RF over R1 V1 plus, all of them are going to be negative because we are multiplying by negative. So this is going to be negative RF over R1 V1 minus RF over R1 V2 minus RF over R1 V3 is equal to Vout. Okay, so this is our final answer. And for example, let's say if RF is equal to, like, all the resistance are equal. Okay, this one should be R2, this one should be R3. Okay, so let's say we have a resistance. If RF is equal to R1 is equal to R2 is equal to R3, for this kind of case we are going to have Vout voltage that is equal to negative V1 plus V2 plus V3, and that's going to be our final answer. I hope this helps. Thanks for watching.